Lesson 118, Minimizing Thermal Energy Transfer. And this experiment will be investigating how different materials can reduce the amount of thermal energy transfer from something like a heat lamp to our experimental setup using these glass containers. To do this, we will use two PocketLab weather sensors, which you can see here, and then two glass jars, a heat lamp, and then some insulating material. We are using, in this example, shredded paper, but your students may bring in all sorts of material like packing peanuts or recycled material, cardboard, that they can use for their experiment. To get started, we need to connect the PocketLab sensors to our app. And for more details on how to do that, you can see videos in some of the previous lessons. So we'll move through this more quickly this time. To get started, turn on the PocketLab device, go to the PocketLab.com/app, and then connect to the PocketLab Weather in the Bluetooth pairing menu. And we will do this for both devices so that we can take measurements simultaneously. On the screen, you will see the default measurement conditions, which we can change by going to this graph select icon. And in this case, we want to use the internal temperature. This means the temperature sensor that is inside of the PocketLab Weather, as opposed to the temperature probe, which you would plug into the device and has the wire leads attached to it. So we will unselect the measurement conditions and select the internal temperature. We will do this for both devices. On the screen, you will see a line graph of the internal temperature inside the PocketLab Weather in degrees Celsius, which you can change using the ruler icon and the unit select menu. So we will place the sensors inside of the glass jars. It doesn't matter what orientation they're in. And then we will seal the jars with the screw top lids. And as you can see, the heat lamp is already turned on. And then we will start recording data for both containers. The temperature inside the containers will heat up and eventually reach a steady temperature after 5 to 15 minutes, depending on your experimental setup. And then students should take one of the jars and insulate it from the heat coming from the heat lamp and compare the differences in measurements. So we have a Ziploc bag with shredded paper that we will insulate the jar on the right. And then make sure in your experimental setup that you have the jars roughly the same distance from the heat lamp with the same amount of light shining onto the jars. Have students observe the change in temperature over time, and we will collect data and record it over the total length of this experiment, which may last 5 to 15 minutes depending on your particular setup. We are going to stop the data recording and look at our results so far after 6 minutes of the experiment. As you can see from the data, the temperature of the jar and the sensor on the left is still quickly increasing. And you can see that after about 6 minutes, it's reached a temperature of approximately 39 degrees Celsius. Compare this to the temperature of the insulated jar on the right, and after the same amount of time, the temperature has reached a steady temperature of about 33.9 degrees Celsius. So you can see that the insulation was effective in minimizing the thermal energy transferred from the heat lamp to the jar on the right versus the control where there was no insulation and the jar was directly absorbing the heat from the lamp.